One of the key things that is really needed right now is an understanding of fate and availability of PFAS in the environment. PFAS are per and polyfluoroalkyl substances.
We have a project for ESTCP where we're looking to further validate and demonstrate a passive sampler for PFAS. So ESTCP is the Environmental Security Technology Certification Program from the Department of Defense. It's a research and development program.
And really, they fund a lot of research aimed at getting the latest and greatest science tools and engineering tools out for basically environmental restoration, environmental cleanup sites.
So passive sampling can offer a lot of advantages over traditional active sampling approaches. Traditionally, in environmental investigations, we tend to do active sampling. So this relies on collecting bulk media. And what this results in is a total concentration of the chemical that we're assessing.
But we really want a little bit better of a measurement that helps us predict what's going to be mobile in the environment, what's going to be bioavailable to organisms and taken up by fish and things like that, because those are incredibly important questions to ask in deciding how best to clean up and deal with some of these PFAS sites out there.
Serum has been leading the way with developing passive samplers for different chemicals, contaminants. And most recently, they've developed PFASive, which is a dialysis-based sampler specific for measuring PFAS. Dialysis-based samplers, which we also called peepers, are a very simple technique. It's a small plastic vial filled with ultra-pure water. It has a semi-permeable membrane that allows the freely dissolved concentration of PFAS to flow through it.
We can put in sediment or water and leave it for a couple of weeks. It'll absorb PFAS, but what's nice about it is it absorbs the dissolved and freely available PFAS. And that, again,
is a more realistic measure of exposure for our aquatic organisms. It allows us to provide more realistic assumptions. It gives us better quality data, and we're able to conduct more accurate ecological and human health risk assessments because of it. And when we have more accurate risk assessments, that can help us determine the level of remediation that's appropriate and not potentially performing remediation when we might not have to.